Hi, my name is Anthony, and I'll be answering your math question today. So the question today is to find the limit using L'Hopital's rule if necessary. And so in our first question, we have the limit of the form limit of x approaches negative infinity of x times ln of 1 minus 1 over x. So in this case, we have some competing terms here, right? We have x times ln of 1 minus 1 over x. So let's evaluate each part independently. Well, the limit of x approaching negative infinity is just negative infinity, right? And then for the second part, the limit of ln of 1 minus 1 over x, well, 1 over x as it approaches infinity. Since infinity is large, 1 divided by large is 0, and 1 minus 0 is 1, and ln of 1 is 0. So we have negative infinity times 0. Uh-oh, that's not good. We don't want that. We can't use L'Hopital with that. We're going to have to actually massage this equation around a little bit so that we have something that's of an appropriate form. Because in this case, we have something that's growing really big and something that's shrinking really small. And when we try to compare growing to small, it just doesn't work when it comes to derivatives. We want them to both be changing rates so we can then look at the comparison of the rate change instead of just looking at the comparison of the actual things that are changing, right? We want to look at the rates or the derivatives instead. So the way that we do this is we're going to massage this equation around, and instead of having x, we're going to use it as dividing. We're going to divide that x, and we're going to divide it as 1 over x. And that's the same thing as timesing it by x, right? This is so ln of 1 minus 1 over x divided by 1 over x is the same thing, because and we can do the keep change flip, right? We keep that, turn that to multiplication, and then flip the bottom thing 1 over x to x. Same exact thing. We just moved it around. So now when we do the bottom part, 1 over x, it evaluates to a 0, and we have 0 divided by 0, which is what we need, because now we can take derivatives. When we take the derivative of the top part, we have to take the derivative of the interior function. Well, that's the derivative of 1 minus 1 over x, and that's 0 minus 1 over x. So minus 1 over x is going to, that's x to the negative 1, so it's going to be x to the negative 2, or 1 over x squared. Right? And then since there was a negative 1, that's going to be negative, but there's a negative there, so those negatives are going to cancel out, and it's going to be positive 1 over x squared, right? Or we can erase that, right? And that's going to be multiplying the exterior function now, which is ln. So ln's derivative is 1 over whatever's inside, right? So 1 over 1 minus 1 over x, right? And then we're going to divide by the bottom part. We're going to take the derivative again. And we have, oh, it's the same derivative as that 1 over x, right? So in this case, we are going to make a negative 1 over x squared, because we had 1 over x squared, and there was negative there. And now it's positive here, and now it's negative. So look, we can cancel these terms out, right? We're dividing this term, and I mean, we can cancel these components out, right? 1 over x squared and dividing by 1 over x squared. These will divide out from each other, and this negative, we're going to just move that over here, right? And now we have negative 1 over 1 minus 1 over x, and then we have to take the limit of this now as x approaches negative infinity, right? And now this is going to be really straightforward, because this is going to go to 0, right? And then we're going to have negative 1 over 1, which means that this limit is going to evaluate to negative 1. Now for the bottom one, we can't really use L'Hopital's rule. And the reason why is because this thing is in an indeterminate form where we're adding or subtracting some infinities. So instead, let's try plugging in a large number. Let's try 1,000, right? So 1,000 times 5 is going to be 5,000. And then we're going to subtract the square root of 25, and then that's a million, 25 million, right? And then there's going to be another 2,000. And let's take that square root now, right? So just give me a moment to clear my results. It's 25 million 2,000, right? And then we take the square root of that, and we get 5,000.19999. It's very clear here that this is going to be 5,000.2, right? In our long term, right? So we're going to just do 5,000 minus 5,000.2, and it's going to be that we're at negative 0.2, which is the same as negative 1/5. And that's going to be your convergent term for your second limit. All right. Have a good day, and I hope that these answers explain everything well. Thank you. Bye-bye.